Mars, our familiar red neighbor, is hiding a secret, because in the distant future, it's going to go through a violent and spectacular transformation, becoming a world that could rival the beauty of Saturn. The trigger for this change isn't some outside threat. It's a cosmic drama playing out with its own moon, a moon that's on a slow-motion collision course with total destruction. And what you're about to hear isn't science fiction. It's a scientifically supported prediction about just how dynamic and violent our solar system can be. We tend to think of our solar system as a settled, predictable place. The planets trace their familiar paths, the moons follow their leads, and everything pretty much stays in its lane. But the truth is far more chaotic. Right now, as you're watching this, Mars is in the process of pulling one of its moons apart. It's a process happening in agonizingly slow motion, but its conclusion is inevitable. The red planet is going to destroy its own moon, and in doing so, it's going to forge something magnificent. To understand this future cataclysm, we first need to meet the main characters. First, there's Mars itself, the fourth planet from the Sun, a world of rusty dust, towering volcanoes and vast canyons. For all its dramatic geology, it seems like a quiet place today, and it has two companions, a pair of small lumpy moons named Phobos and Deimos. Deimos, the outer moon, is tiny and keeps a respectful distance, but our story is all about the inner moon, Phobos. The name Phobos comes from the Greek god of fear, and as we're about to see, it's a fitting name for a moon with such a terrifying destiny. Phobos is, well, it's strange. It's not a majestic sphere like our moon. Instead, it looks more like a potato, a pockmarked chunk of rock just 17 miles or 27 kilometers across at its widest point. It orbits Mars incredibly closely, completing a full lap around the planet 3 times a day. In fact, it's so close that if you were standing in certain places on Mars, you wouldn't even be able to see it, because the curvature of the planet would block your view. For a long time, scientists thought Phobos and its sibling Deimos were captured asteroids, drifters from the asteroid belt that got snagged by Mars's gravity. But their nearly perfect circular orbits don't quite fit that theory. More recent ideas suggest they formed from a disk of debris that was blasted into space when a giant object struck Mars billions of years ago. But whatever its origin story, the final chapter for Phobos is already being written. So here's the central mystery. Phobos is getting closer to Mars. Every century, its orbit shrinks by about 6 feet, or 1.8 meters. Now, that might not sound like much. 6 feet is barely taller than a person. But in the celestial dance of orbits, where things are supposed to be stable for eons, this is a dramatic and unstoppable inward spiral. This isn't a gentle slide, it's a death sentence handed down by gravity. So, what's going on? Why is Mars being so nasty to its own moon, pulling it to its doom? The answer lies in a powerful, invisible force that governs much of the cosmos. A force that is stretching Phobos to its breaking point. This same force is at work between the Earth and our moon. It's the reason we have tides. The moon's gravity pulls on Earth's oceans, creating a bulge of water on the side of Earth facing the moon and another on the side facing away. As the Earth rotates, these bulges move across the planet as high tides. But here's the key. The Earth's rotation is faster than the moon's orbit. This means the tidal bulges on Earth are always slightly ahead of the moon. This forward bulge of water has its own gravitational pull, and it tugs the moon forward, giving it a tiny boost of energy. This has the effect of slowly pushing our moon into a higher orbit. causing it to drift away from us by about 1.5 inches every year. On Mars, the situation is reversed, and that reversal is what seals Phobos's fate. Phobos orbits Mars much faster than Mars rotates. While a Martian day is just under 25 hours long, Phobos whips around the planet in less than 8. Because of this, the tidal bulges that Phobos raises on Mars, bulges of rock, since Mars has no oceans, actually lag behind it. Instead of giving it a push into a higher orbit like our moon gets, this drag acts as a brake, stealing its orbital energy and causing it to spiral inward. This brings us to a critical concept in astrophysics: the Roche limit. The Roche limit is an invisible boundary around a massive body like a planet. Inside this limit, the planet's tidal forces, that stretching force we've been talking about, are stronger than the gravitational force holding a smaller body like a moon together. Think of it like this. Imagine you're holding a loosely packed snowball. From a distance, it holds its shape, but as you bring it closer to a giant heat source, the outer layers start to melt and break away. The Roche limit is the gravitational equivalent of that melting point. For a moon, it's the point of no return. Once a moon crosses this line, it will be torn to shreds, and Phobos is falling directly toward it. Based on its current rate of orbital decay, scientists predict that in about 30 to 50 million years, Phobos will finally cross Mars's Roche limit. The moment it does, the destruction will be swift and absolute. The tidal forces from Mars will overwhelm the Moon's own gravity. The side of Phobos facing Mars will be pulled much more strongly than the side facing away. It will start to stretch out, deforming like putty. Fractures will race across its surface, and in fact, the deep grooves we already see on Phobos today might be early signs of this structural strain. Then, it will be ripped apart. Phobos will disintegrate into a cloud of billions of pieces, from fine dust to massive boulders. Because all this material is still in orbit, it won't just fall to the planet. Instead, the debris will spread out, forming a new, dense ring system around Mars's equator. The red planet will, for a time, become a ringed planet. But what would these rings look like? Don't picture the brilliant icy white rings of Saturn. Phobos is made of dark, carbon-rich rock, what's known as C-type material, similar to many asteroids. So the rings it forms will be dark, dusty, and far less reflective. They would be more like the faint, almost invisible rings of Jupiter or Neptune. While maybe not as dazzling as Saturn's from a distance, the view from the surface of Mars would be nothing short of breathtaking. A dark, dramatic arch of its former moon would stretch across the alien sky. This new Martian ring system isn't expected to be permanent. Over millions of years, the ring particles would continue their slow spiral inward, eventually raining down onto the Martian surface as a constant dark meteor shower. Scientists estimate the rings themselves could last anywhere from 1 to 100 million years, a fleeting moment in cosmic time, but an incredible spectacle nonetheless. But wait, there's more. What if this isn't the first time Mars has done this? Some scientists now believe that Phobos might be just the latest in a long line of Martian moons. A compelling theory from researchers at Purdue University suggests a grand, repeating cycle. It starts with a massive impact on Mars billions of years ago, which created a huge debris ring. That ring eventually clumped together under gravity to form a moon. That moon was then pulled inward by tidal forces, just like Phobos is today, until it was torn apart at the Roche limit, creating a new ring. And from that ring, a new, smaller moon was born. This cycle, moons born from rings, and rings born from the destruction of moons, could have repeated itself 3 to 7 times over Mars's history. Each time, the resulting moon would be smaller than the last. If this theory is correct, Phobos isn't an ancient captured asteroid but a relatively young moon, maybe only 200 million years old, born from the ashes of its predecessor. Its impending doom is simply the next step in this ancient, violent cosmic recycling program. This idea helps explain some puzzles, like the mysteriously tilted orbit of Mars's other moon, Deimos, which could have been knocked into its strange path by a much larger, earlier moon. To solve this mystery for good, we need to get a closer look at Phobos itself. That's the goal of Japan's Martian Moons Exploration Mission, or MMX. Scheduled to launch in 2026, the MMX spacecraft will travel to the Martian system, land on Phobos, collect over 10 grams of rock and dust, and then return that sample to Earth by 2031. By analyzing the composition and age of the material from Phobos, scientists hope to finally confirm its origin. Is it a captured asteroid, a piece of an ancient collision, or a second or third generation moon born from a ring? The samples MMX brings back will hold the key. Let's just take a moment to imagine this distant future. Tens of millions of years from now, long after Phobos has vanished from the Martian sky, a dark, majestic ring will encircle Mars. For any future inhabitants, human or robotic, the view would be spectacular. During the day, the ring would cast a thin, sharp shadow on the planet's surface. At sunrise and sunset, the particles would catch the faint sunlight, creating a stunning celestial arc. The night sky would be transformed. Instead of a tiny, fast-moving point of light, a broad, dark band would stretch from horizon to horizon, obscuring the stars behind it. And that band would be a constant, solemn reminder of the moon that used to be a monument made from its own destruction. This transformation highlights a profound truth about our universe. It's not static. It's a place of constant change, of creation and destruction on a scale that defies human imagination. The planets and moons we see today are not in their final forms. They are all part of an ongoing story, a story written by gravity, time, and violent collisions. The story of Phobos is just one of many incredible sagas playing out across our solar system. If you love exploring these cosmic mysteries and want to stay updated on the latest discoveries in space and astronomy, make sure to subscribe and hit that notification bell. Now I've got a question for you. What do you think is the most fascinating future event predicted for our solar system? Let me know down in the comments. So, will Mars develop rings like Saturn? The answer is a resounding yes, though they'll be darker and much more temporary. Phobos is doomed. It's on an unchangeable path toward its own destruction, a process driven by the same gravitational forces that shape the entire cosmos. In its death, it will give Mars a temporary, terrible beauty, transforming the red planet into a ringed world. The fate of Phobos is a powerful reminder that the solar system isn't a quiet, peaceful clockwork, but a dynamic and evolving stage where even moons can die and be reborn as something entirely new.